Our lesson on section 1.3 involves solving linear equations, which is a concept that you have seen various times in Algebra 1 and in geometry, so a lot of this is going to seem like review. Now, our first problem, 4x plus 7 equals 27. You're going to want to collect everything that's the x to one side and the non-x's to the opposite side. So we're going to go ahead and subtract 7 from both sides, giving us 4x equals 20. And then we'll divide both sides by 4. So x equals 5. Now hopefully that didn't give you any trouble. Let's look at number 2. 5 halves x equals 20. Well, a couple ways we can get rid of a fraction, but the quickest way is to just multiply by his reciprocal. So the reciprocal of 5 halves is 2/5. So we're going to multiply both sides of the equation by 2/5. 5 halves and 2/5 will cancel. And 20 times 2/5 is 8. Okay, moving along. When you get to number 3, there's a's on both sides of the equation, and it doesn't matter if you bring them to the right or to the left. I'm going to go ahead and bring the a's to the right. So I'm going to subtract 3a from both sides, and that's going to bring all the a's to the right. Now since I brought all the a's to the right, the non-a's have to move to the left. So I'm going to go ahead and take this negative 8 and I'm going to add it to both sides of the equation. So over here on the left-hand side, you have 21 equals, and then 9a minus 3a is 6a. And we're going to divide both sides by 6. And 21/6 reduces to a 7 halves. In Algebra 2, we always prefer our answers to be reduced improper fractions as opposed to a decimal, but I would also accept a decimal. Now in number 4, we're going to have to use the distributive property and go ahead and distribute the 4 into the parentheses. So we have negative 12x plus 4, and then same thing in the next part of the equation, negative 10x plus 40, and then there's still a minus 14x off to the side. Now when you look over here on the right hand side, you've got some like terms, negative 10x and a negative 14x, that you need to combine. So we're going to combine those like terms and get negative 12x plus 4 equals negative 24x plus 40. This time I'm going to bring the x's to the left hand side, so I'm going to go ahead and add the 24x to both sides of the equation. And just to save me some time, I'm going to go ahead and subtract the 4 to move it to the right side of the equation. So we end up with 12x equals 36, and then when you divide by 12 on both sides, you end up with x equals 3. Okay, when we get to the next section, we've got a bunch of fractions, and I don't know about you, but I'm not a fan of fractions, especially in my equations. So what we're going to do is we're going to multiply the entire equation by the least common denominator for all of your denominators. So big parentheses around the entire thing, and I look at my denominators, which are 6 and 12. And the least common multiple for 6 and 12 is a 12. It's the first number that both of them will divide into. So I'm going to put a gigantic 12 out in front of the whole problem. And I'm going to go ahead and think about distributing this into the whole equation. This is legal as long as you remember to do it to every single part of the equation. So we have 12x minus 12 times 5, 6. You could either do that on your calculator or in your head. It's quicker if you do it in your head, and it's also quicker if you do the division part first. So I always take the 12 and then I'll divide it by the 6. That gives me a 2. And then multiply that by the 5, so that's why we have a negative 10. And then 12 times 2/12 is 2. And we're going to go ahead and solve this like normal. So I'm going to add the 10 to both sides. And we get 12x equals 12. And when I divide by 12 on both sides, you get x equals 1. Now I'm showing a little bit more work than I expect you guys to show in the next couple weeks. As you prove to me that you know what you're doing, I'm okay if you show a little bit less work. Okay, here on number 6, big parentheses around the whole thing. Now the LCM, or the LCD, for 4, 5, and 2 is going to be the number 20. So a big 20 outside of the whole equation. And we're going to go ahead and distribute this 20 into every part of the equation. So that leaves us with 20 times 3/4 is a 15x. 20 times 3/5 is a 12. 20 times 5 halves is a 50x. And 20 times 1/4 is a plus 5. So now we're going to bring all the x's to one side. I'm going to go ahead and bring the x's to the right-hand side, which means I'm going to bring the non-x's to the left. So I'm left with negative 17, ooh, that's ugly, equals 35x. And then let's divide both sides by 35. And the answer's not so great. It's negative 17/35. A lot of times these answers come out gross. And that's fine because it's algebra 2, and as long as you leave it as an improper fraction or a reduced fraction, you're fine. Okay, on number 7, we have a fraction multiplied into a set of parentheses. So before I get rid of the fractions, I'm actually going to go ahead and I'm going to distribute this fraction inside. So 3/4 times 4/5, the 4's would cancel, and that'll leave you with 3/5 x. 3/4 times 2 would give us, let's see, minus 3/2 equals 11/4. So now, big parentheses around the whole entire equation. I need something to get rid of a 5, a 2, and a 4, and that's going to be a 20. That's the LCM for 5, 2, and 4. 20 times 3/5, let's see, that would be a 12x. 20 times 3/2 would be a minus 30. And then 20 times 11/4 would be a equals 55. So now there's only one set of x's in the problem, so I'm going to go ahead and add the 30 to the other side. You get 12x equals 85. And then divide both sides by 12. And once again, we've got kind of an ugly answer, but again, algebra 2, we get ugly answers. So we got to leave our answer as a reduced improper fraction, and this is it. Alright, whoops. The next set of problems are proportions, and if you remember, when you have a proportion, you just cross multiply. So this diagonal is going to be multiplied together, and this diagonal is going to be multiplied together. It doesn't matter where you start, so I'm going to start with that first diagonal that I circled in. I'm going to get 6x plus 12, because the 6 is going to have to be multiplied by the x and the plus 2. So 6x plus 12 equals, and then when I do the other diagonal, I get 4x minus 12. Now I want to bring all my x's to one side, all the non-x's to the opposite side. So I'm going to subtract the 4x, and at the same time I'm going to go ahead and subtract the 12 to cancel out these. So I end up with 2x equals negative 24, and when you divide both sides by 2, you get x equals negative 12. Okay, when you get to number 9, it is technically a proportion, but what I notice is instead of being a fraction equals a fraction, it's not quite in that format. So I need to isolate that fraction. So the first thing I'm going to do is I'm going to subtract that 4 from both sides. And that's going to give me negative 2x plus 10 divided by negative 5 equals 9. Now, you can think of it as a proportion if you throw the 9 over a 1, and now it is a cross-multiplying problem. So you can go ahead and think of multiplying this diagonal and then equaling it to that diagonal. So we have a negative 2x plus 10 equals a negative 45. We're going to subtract 10 from both sides. We have a negative 2x equals negative 55. And then when you divide both sides by negative 2, the negatives are going to cancel out. So you have x equals 55 halves. Again, reduced improper fraction is a little better than a decimal for algebra 2. The only time a decimal would win out is if it was an application problem, where a decimal would be more appropriate because it's a real-life answer. Okay, number 7. Speaking of applications, we've got a real estate broker whose base salary is $18,000. She gets a 4% commission on all of her sales. So how much must she earn in order to have $55,000 total? I'm guessing they mean for the year. So we'll set up a little formula. Her total earnings are going to equal her base salary And then she's going to make 4% of her commission. So we write 4% as 0.04 and then times whatever her commission on her sales is. Let's call that sales instead of commission. So let's fill in what we know. We want her total salary to be $55,000. We know her base salary is $18,000. And the only thing we don't know is her sales, and I'm just going to call that an X. So now we've got a two-step equation to solve. I'm going to go ahead and subtract the $18,000 away from the $55,000. And that gives me, let's see, $37,000. .04x on the other side. And now we're going to divide both sides by 0.04. And remember, we're finding the amount of sales that she has to accrue. This is going to be a pretty big number because they're not going to pay you for selling nothing. So go ahead and divide those on your calculator and you get $925,000. And real estate broker generally means you're selling properties or houses. So that's, not really that many houses. So that makes sense to me. If I came out with a number that said she needed to sell, $1,400, that would not make a lot of sense. So you want to rethink your answer in that case. Okay, the next problem. You have a summer job that pays $5.60 an hour. You get $8.40 an hour for overtime, which is anything over the first 40 hours. How many hours of overtime must you work in order to earn $287 on your paycheck? So when we think about this, your paycheck, let's assume you work over 40 hours. You would get your regular rate times your first 40 hours, and then you would get your overtime rate times your extra hours. So whatever that's going to be. So let's think about what we know. Our paycheck needs to be $287. And we know that the regular rate is $5.60. Now let's assume we're working overtime, which they kind of said we are. I do not know how many extra hours I'm working, but I do know that the overtime rate is $8.40. So it's going to be multiplied by how many overtime hours I work. So on my calculator, first thing I need to do is calculate 5.6 times 40. I think that comes out to 224. So 287 equals 224 plus 8.4h. And then we're going to solve. So we're going to subtract 224 from both sides. That was my regular pay for my first 40 hours. And, oh geez, let's see. 63 equals 8.4 hour times the number of hours, and then when we divide by 8.4, which is how much we get paid for each overtime hour, we end up with 7.5 hours of overtime. Okay, very good. A new iPad was recently purchased in Algonquin for $464.40, and that includes the tax. The tax rate in Algonquin is 8%. We need to go backwards and figure out the price before the taxes were added in. So when you buy a product, the way the cash register calculates it is, they're going to say your total is what we're going to call our subtotal, which is the price before taxes. Times, and then 1 plus your tax rate. Now the reason it's 1 plus your tax rate is because 1 represents 100% of your subtotal, and then the tax rate is just going to be another smaller percentage of your subtotal. So rather than splitting this into a separate addition problem, I like to write it this way. So we know the grand total on our receipt was $464.40. I do not know the subtotal, which is the amount before the taxes were added in. However, I do know that taxes were 8%. Now when you use an algebraic equation, you got to write 8% as a decimal. So 0.08. Okay, that's also known as 464.4. 1 plus 0.08 is 1.08. So let's go ahead and divide by 1.08. And when I do that on my calculator, I get $430. Seems like a realistic amount if I think about what's going on in this problem. Now there's other ways to do that problem. Sometimes they take more steps than what I showed you. Do whatever way is easy for you to understand, because this problem will show up on quizzes and tests. And that's our lesson on 1.3.